What's up, guys? Mr. Jones here, and we are on to a new unit. We're on to functions. Functions. And believe me, I am going to put the fun in functions. So here we go. We got three definitions, okay? And functions is going to be a fourth one. We're going to define that after. I want to go over all this first. A relation, right? A relation, I just say, is a set of ordered pairs. So just think about that. Ordered pair, if you don't remember, an ordered pair is kind of like when we have a point, like a point on a graph. So like 1 comma 0 or 2 comma 3 or anything, right? The first value is an x value. The second value is a y value, okay? And so a relation is just any set of these ordered pairs, right? So there could be two ordered pairs in the set. There could be 50. There could be however many. It's just any set of these ordered pairs. Okay, that's a relation. Okay. And then domain and range, you might have heard these words before. These are specific components of the relation. Okay, so the domain is the set of all x values. Okay, and then the range is the set of all y values. Okay, and so that's really important that you tie those words. So domain means x values, range means all y values. How I remember that, domain comes before range in the alphabet, just like x comes before Y in the alphabet. Okay, so that's how I remember that. Helps a lot of kids remember it too. So, but what does that mean? What if we were to ask for like the domain and range? What would that actually look like? Okay, so let's jump into these examples here, and you'll see what I mean. Okay. So example one, if I just have just a random relation, like I'm just going to make these numbers up. So if I have -2 comma 4, 0 comma 7, and 5 comma -1. If I have that table of values, right, my x values are here, my y values are here, okay? And so this would be an example of a relation, okay, because it's just a set of three ordered pairs kind of grouped together, okay? And again, when you list it in a table, just remember that this is kind of the same as saying -2 comma 4, 0 comma 7, and 5 comma -1, kind of writing it like that ordered pair in the parentheses. Okay, so that's the same, the table of values is the same as saying this, okay? But if I'm asked for what the domain is of this, okay, I can do that, okay, because that's just, again, the set, kind of, it's a part of this set, but it's just the x values, okay? So I can ignore the y values when I'm asked about the domain, and I think, okay, the domain is just -2, 0, and 5. And so I'm going to make my fancy bracket, -2, 0, and 5 is my is my domain, okay? Because that's just a set of all the x values within this relation, okay? And then the range is just the opposite. The range is you can ignore the x values and it's just the y values. Y values -1, 4, and 7. Notice I put it in numerical order from lowest to highest. That's usually the right thing to do, is to order it like that. Okay, so you might be saying, that's so easy. Why is that necessary? Okay, this is, again, this first lesson, laying the foundation. It's going over the basics because this will get a little bit trickier using domain and range later on. Okay, so just trust me on that. We're going over the basics right now. Okay, and so you notice I have these graphs up here too. Okay, I have these graphs up here. And right with any ordered pair, right, an ordered pair, like I said, kind of translates to a point on the graph, right? Because if this is the x-axis and this is the y-axis, I can plot these points on the coordinate plane, right? So for example, the point -2 comma 4, -2 on the x, so I go over from 0, -2, and then the y value +4, so up 1, 2, 3, 4. So that first point would be right there, okay? Second point, 0 comma 7. So 0 on the x, so I'm not moving over side to side at all. And then 7 would be up 1, 2, 3, 4, 5, 6, 7, up 7. Okay, and then 5, -1. So 5 on the x, so I move over to the right 5, 1, 2, 3, 4, 5. And then -1 on the y, so I move down 1. So that's just, again, if you're unfamiliar with that, if you feel like, what's a coordinate plane? I've never seen that. Look up just how to graph or plot points on a coordinate plane. That's something you should have seen already by the time you get to Algebra 1, but you can do a search for that. That's something you can look up if you're unfamiliar, okay? So notice, okay, we have our table of values, our graph, and then the domain and range given from that. And there's more to it too. But the big thing with functions that I want you guys to take away is that there are lots of different ways of displaying the same thing, okay, right? Like this table of values is a way of displaying what this relation is, okay? But then the graph as well is another way of displaying what the relation is, okay? There's some other ones too I'll go over in a little bit. But that's an example, okay? Let's jump into example two. I'm going to do a similar one, okay? And there's going to be a reason for this. You might be saying, I don't need to see another one of those, but there is going to be a reason, okay? So if I have 2, 7, 5, 1, and 5, -4, okay? And then I'll graph those, and then I'll do the domain and range. So 2, 7, there. Again, that's the y-axis. This is the x-axis. 5, 1, and then 5, -4. I graphed those pretty quick, but yeah, that's another relation. Okay, just again a group of ordered pairs, and then so I showed it in the table. I can show it in the graph, and then if I list the domain and range, I would get the domain as 2, 5. Notice 5 is listed twice, but I don't need to write it a second time. Okay, it's just a set of all the different values. So 5 is already listed here, so I don't need to list it again. And then the range is, again, numerical order, -4, 1, and 7. Again, a set of all the x values is the domain, a set of all the y values is the range. So there you go. I hope that's just the basics of it here, okay? But we're going to get into, right, the name of the unit is functions, okay? And that's another type of specific relation that we're going to go over right here, okay? So let me do some erasing here, and then I'll show you. Okay, so we're back here. And so I have the definition of function listed here. And I define it as it's a type of relation. Again, so it's a type of one of these sets of ordered pairs for which each domain value, and again, every time I see the word domain, I just immediately think x. So even it'll say domain, but you just think x values. Which each domain or x value has exactly one range. And again, same thing, it's just every time I see range, I think y values, okay? So, which each domain value has exactly one range value. So let's just think about what that means. And you see I have this question down here that says, is example 1 or example 2 a function? Okay, so that's going to be a big part of this unit too, is kind of figuring out, is the relation a function? So we want each x value to go with exactly one y value. That's the big goal, okay? And so the big thing that you look for with relations to determine whether it's a function or not is, does every x value have exactly one y value? Or an easier way of saying, the big question is, do the x values repeat? Do the x values repeat? Because if the x values repeat, okay, if there's more than one of the same x value, then it doesn't have exactly one x for every one y. Okay, that would mean that one x value has 2 or 3 or however many times it repeats. Okay, so that's even a little bit easier to understand. Do the x values repeat each other? Okay, that's going to determine if it's a function or not. And we do not want them to repeat. Okay, if they repeat, then it is not a function because that x value is going to be tied in with more than one y value. Okay, and so let's look at this. Okay, so answering this question right here. Again, do the x values repeat? -2, 0, 5. No, those are all different. Okay, those are all different. But if I look at example 2, 2, 5, 5. Repeating x values right here. Okay, repeating x values. And so that is no good. So this, number 1, is a good function. And then number 2, not a good function, no good, because of those repeating x values. And the last thing I'll go over how we can determine that on a graph too. But example 1 is a function. Example 2 is not because of those repeating x values.